Alright kids, today we're taking a look at a block which has been placed in the back of a truck. Now the block's not tied down, it's just resting on the flat truck bed. Now if the truck speeds up gradually, the block's just going to move along with the truck. But if the truck speeds up abruptly, then the block's going to slide right out of the back of the truck. So given only the coefficient of friction between the block and the truck, we're going to solve for the maximum acceleration of the truck that will keep the block from sliding right out of the back of the truck. Now sitting at the center of this problem is Newton's second law, which says the net force on an object is equal to its mass times acceleration. And the symbol right here is what we call the net force. Or better put, it's the sum of all forces on an object. So if the net force is the sum of all forces acting on an object, then we need to take a look at the forces which are actually acting on this block as the truck speeds up. See, first there's gravity, which is pulling the block downward. And then there's the force by the truck, which is holding up the block. And that force is referred to as the normal force, which occurs anytime two objects are in contact with each other. And the last force is friction. You see, friction tries to keep two objects from sliding against each other. So if the truck moves forward, friction's going to try to pull the block forward with the truck. Now the truck's going to speed up in the x-axis. So first we're going to apply Newton's second law to the x-axis. Now horizontally, the only force which is acting on the block in the x-axis is in fact friction. So we're going to say the friction force is equal to the mass of the block, which we don't know, times the acceleration in the x-axis. Now we do know that friction, by definition, is equal to mu, the coefficient of friction, multiplied by the normal force. But the issue is, we don't know what the normal force is. So to find the normal force, we're going to need to take a look in the y-axis. You see, applying Newton's second law on the y-axis, there's the normal force upward, and then there's the force by gravity downward. So I'm going to say Fn is upward or positive, and the force by gravity is downward or negative. And those two forces add up to be m times the acceleration of the block vertically. Now the truck's only moving horizontally, this block isn't taking off like a rocket, so the acceleration is actually going to be 0, which makes everything over here 0. Or pulling Fg over to the other side of the equal sign, you'll see Fn is equal in magnitude to Fg, the force by gravity, or weight of the block. Now, the force by gravity is given by the mass of an object, in this case the mass of the block, which we still don't know, multiplied by g, the acceleration due to gravity. So subbing that in right here to this equation, we get the normal force is equal to the mass of the block times g. Now it seems like we're making a problem here because we don't know the mass of the block here and we don't know the mass of the block over here. But look at what happens when we substitute this expression for normal force in over here. We get friction is mu times the mass of the block times g, and then substituting that term for friction in way up here, we get this expression, which relates mu, the mass of the block, and g to the actual acceleration of the truck. And you'll notice, the mass of the block cancels out. We never needed the mass of the block. So now we can plug our values from the problem into this equation. So mu is 0.2, g is 9.8, assuming this is happening on Earth, and we find the maximum possible acceleration of this truck that will keep the block from sliding out of the truck bed is 1.96 meters per second squared. So I hope you found this useful. And on that note, that's all for now.